What's going on, guys? Today we're going to be taking a look at the third unit of AP Calculus. What I'm deciding to be is the third unit, and that unit is going to be related to graphs and derivatives. So how derivatives, how you can use a derivative to figure out what the graph of a normal function looks like. Buckle in, because we're going to be doing this in 10 minutes or less, hopefully. So without further ado, let's get right into the video. But before we get started really quickly, keep in mind that anything boxed in blue, anything written in blue and then boxed in blue, that's the key concept that I'm referring to when I'm making that video. So if you're confused on that concept, be sure to go look that up in your textbook or in another source or one of my videos. But if you're stuck on why I did a problem a certain way, check out the key concept in the blue box. All right, now let's go ahead and get into the video. All right, so we're given a function. We're told it is f prime. That's probably going to be something really important that we should keep in mind. But we're told what f prime of x is, and we want to find the intervals where f is decreasing. Now, based on the increasing and decreasing test, f prime is going to be decreasing when f prime is going to be negative. So we're going to be looking for where f prime is negative. I did not specify what graph this is, but actually, I don't need to specify what graph this is, because you can tell by the way this graph is shaped and where this vertex is. This is the point 0, -4, and you can also check that at -2 and +2, this value comes out to be 0. So you know that this graph is the graph of f prime, and we're looking for where f prime is negative. And as we can see that this part in red, those are all negative values, negative outputs. Therefore, that is where f prime of x is negative. So therefore, since f double prime, not f double prime, this is just f prime. Since f prime of x is less than 0, meaning since f prime of x is negative on the interval, make sure you state the interval. Since the first derivative is negative on the interval from -2 to 2, then f must be decreasing on the interval from -2 to 2. Go ahead and check out the increasing, decreasing test if that sounds confusing to you. All right, next up we have a two-part problem. First off, we're told the second derivative of some function is going to be 2x minus 6, and we're told that it is continuous, and we're told that it is continuous. I don't know why I say f prime, but f double prime is continuous, and if f double prime is continuous, that probably means that f prime and all the orders before it are also going to be continuous. And we're asked to find the values of x where, oops, sorry about that, my screen went whack. But we're asked to find all the values of x where f has a point of inflection. Remember, a point of inflection is a point where the graph changes concavity. So for example, if we have something like this right here, this point right here in blue, that would be what we know as an inflection point, abbreviated as IP. And this occurs when the second derivative, so this occurs when f double prime is equal to 0. So in order to find a point of inflection, we have to find where the second derivative is equal to 0. So we set the second derivative, which we're given, equal to 0. We solve, we get x equals 3. But for all we know, we have to test, oops, I didn't mean to do that. We have to test to make sure that that second derivative is valid, or so that inflection point is valid. So we check to the left of 3, and we plug in something like, say, -2, and we're going to get here, if we plug in, or sorry, say we plug in something like 2. We plug in something like 2, we get 4. That's not 2, we get something like 4. And 4 minus 6 is -2. That just goes to show that is a negative number. So that is why, oh, I didn't want that. So that is why we have a negative on our sign chart over here. We're going to do something a little bit bigger than 3, maybe 4. 2 times 4 is 8. 8 minus 6, that is 2. That is a positive answer. So therefore, it is positive on those other intervals past 3. So since it changes sign, so since f double prime changes from negative to positive at x equals 3, that's what you have to write in your answer in order to show that is an inflection point. F therefore has a point of inflection at x equals 3. In part B, we're asked to find where f is concave up and concave down. Remember, based on the concavity test down here, it is concave up if the second derivative is positive, and it's concave down when the second derivative is negative. So obviously we're just going to use our sign chart up here to help answer that question, since f double prime is negative from what seems to be, this is negative infinity out here, what seems to be negative infinity to 3, f therefore is concave down on that interval. And since we have positive values of f double prime from 3 to infinity, we can therefore conclude that f is concave up on the interval from 3 to infinity. If this whole problem didn't make sense, make sure you go over and check out the concavity test. All right, let's see if we can find the values of x where f has a relative minimum. Well, we should note that we're given a value for f prime. We're given the graph of f prime of x. That's vitally important. Now remember, we want to find wherever a relative maximum or minimum occurs, it will occur at a critical point. And a critical point occurs when the first derivative is equal to 0. Now, therefore, we can see right here, as labeled here on this diagram, that -2, that x equals -2, or f prime of -2 has an output of 0. So therefore, f prime of -2 is a critical point. And there's two ways to determine if it's a relative minimum or a maximum. One way is by the first derivative test, which I outline right over here. So you state your critical point. So the critical point is -2, and then you do a little sign chart. Now, of course, you can't use sign charts in the AP test, so you verbally do it. So obviously, since the first derivative is negative on intervals less than -2 and positive on intervals to the right of -2, therefore it changes sign across -2. That statement means that f has a relative minimum. Check out, read the wording if that confuses you. I'm not going to go over the wording so that we can finish in 10 minutes. The other way you can do it is via the second derivative test. And the way the second derivative test works is you identify the critical points. You identify, all right, so you say the critical points, and then you use the second derivative. So if the second derivative, so I'm actually going to write this over here. If the second derivative is positive, so it's greater than 0, then you're going to get a relative minimum. And if the second derivative is less than 0, you're going to get a relative maximum. And if the second derivative is equal to 0, the test it's indeterminate. I'm just going to write IND. Indeterminate, you're going to have to use the first derivative test. So I'll just put an arrow over here saying use the first derivative test. You'll have to use the first derivative test if it's equal to 0. So another way you could have done it is you could have set the second derivative. You could have found what the value for the second derivative is at that point. And obviously, if we draw a line of tangency, if I can get a good line of tangency, that's going to be as good enough as we can get. Obviously, that line of tangency has a positive slope, and since it has a positive slope, we can then determine that the second derivative is at least positive, so we can check that box off. And since the second derivative is greater than 0 and the first derivative is equal to 0, we have a relative minimum. Check out the first and second derivative tests if any of that was confusing to you. Finally, we're going to wrap up with this last question right here. We're told that f is a twice differentiable function, and we need to order the output at 10, its output of the first derivative at 10, and its output of the second derivative at 10 from smallest to largest. Let's see if we can do that right away. Well, obviously, we can take a look. This is f of 10 right here, whatever this output is, and we can clearly see that this output is right here at 0, so therefore the f of 10 has to be 0. You can notice this red line here is the tangent line, and we notice that that tangent line seems to look like a positive tangent line, so therefore the first derivative, well, we don't know what its value is, we know it has to be positive. And if we take a look at this graph as a whole, it seems to maybe kind of look and do something like this, and maybe it starts coming back down, but this general shape is a concave down shape. And since it's concave down, that means the second derivative has to be negative. So therefore, the second derivative is the smallest, followed by the general output at 10, since that's 0, followed by the first derivative, since that is positive. This is just kind of using everything you know about this unit to answer this question, but it is a common AP multiple choice style question. So just practice these types of questions. I most definitely guarantee there will be a question like this on the AP exam. Thank you guys so much for watching this video. If you find these videos helpful, please subscribe. It really shows YouTube that I really make good content on here. Leave a like and comment with other videos you want me to make. And thank you guys so much for watching, and I'll see you guys in the next Rapid Review video. See you guys until then.